Okay, minasan, konnichiwa, Zamurai Engineer desu. So, in this current live stream lecture, we would like to continue our discussion, actually start the new one on topic about plumbing vents. Okay? So, vents is so important in the plumbing system that it necessitates actually a separate chapter on its own in the code, in our country's code. It has a separate chapter, and because of that, we also have more details about vents in this segment. Okay, but before we start, I would like somebody to confirm our sound check. Okay, shout out to Cyrene for confirmation. Therefore, let's proceed. Okay. So, plumbing vents. So, to understand the purpose of this, we must understand the purpose of plumbing traps. The main area of concern is the trap. What is a trap? It is the required for all fixture drains connected to DWP pipes. So all the fixture drains, again, that are connected to the WP pipes, we are required to connect a trap. Okay? A trap can be a separate fitting, such as a P-trap for a sink or a shower, or can be part of the fixture, such as the trap in a toilet, meaning the bowl, the toilet bowl. So the toilet bowl has an included trap on its own. So we don't need to install a separate trap for the toilet bowl or the water closet. So we already talked about this, but here we emphasize this point. So take note of the emphasis. Okay? A trap maintains a water seal. That is the main purpose, water seal. We want to seal something and we use water to do the sealing for us. Okay? That keeps noxious meaning foul smelling, okay? And potentially explosive sewer gas in the pipes and away from the air in the home. Okay? That's correct. For those foul smelling gases are actually a potential explosive gas because they are actually the content of that gases are the same content on natural gas. Okay, so the same elements involved in those foul smelling gases in the water closet, the same in natural gas. Okay, so if a natural gas could be a potential explosive gas, so thereby the same is true with the foul smelling gases in water closet. So we want that gases away from the air in the home. So that's why we want that gases to be taken out to the outside environment. So taken out from inside of the bathroom to the outside air environment. Okay. So meaning to say, there is a principle in explosive gas. It is dangerous if the explosive gas is actually concentrated. Okay, meaning the density of explosive gas elements compared to the total amount of the gas particles. So the ratio is high. So the concentration of explosive gas is high, meaning it is more dangerous. That's why we want to expose that gases to open air so that it could immediately lessen its concentration. The concentration will be become lower and lower. The concentration will decrease, okay, because there are plenty of nitrogen in our air. Actually, our air, how much? 79% nitrogen. Okay, so if it mixes with the open air with 79% nitrogen, so immediately the concentration of this foul-smelling gas will decrease, and therefore the potential for explosion will also decrease. Okay, decrease. And together with it, noxious. Okay? Noxious is another word for foul smell or bad smelling gas. Okay? So the noxicity, okay, will be reduced because of concentration also. The same principle. Because of lesser concentration, it cannot be anymore smelled by human. Because of less and less concentration, so it will not be able to stimulate our human sense of smell. Okay, so that's the reason why we take away those gases from inside to the outside of the house. When you stop using the fixture, some of the water remains in the trap. Not only the water closet. Any fixture has a potential for this. Okay? Any fixture potential because there are waste and drain of different elements, dirt, so on. There is always a potential for noxious or explosive gas. Okay? So unwanted gases. Okay? Not only water closet. And some of the water remains in the trap and recharges the trap's water seat. Okay? That is the process on why the seal is basically effective, because it recharges the sealing water, the water's seal. It recharges. If you, for example, take a look at the water closet. Let's focus our attention to that. Okay? If you pour in an amount of water in the water closet, the water seal will be replaced by the new poured water. So that's why the old water that could be harmful or noxious water could be uh, taken away, going to the uh, outside of the building, or to the what to the drain, the end of the drainage system. Okay, and when water flows in a pipe near a trap, the suction caused by the flowing water can create enough negative pressure, okay, at the trap to pull the water out of the trap. This is the what is happening, really happening. Okay, so since we pour in an amount of water, it caused negative pressure at the trap and pull the water out of the trap and replace it. No, this is sometimes called siphoning the trap, because it is similar to what happens when you use a hose to siphon fuel, for example, out of fuel tank. Okay, can you imagine that siphoning of what? For example, if you have a container of fuel and you want to take the content or the fuel inside to another container. So what you will do is use a hose, small hose, for example, and then initially suck the air on the hose in order to initially suck the uh, the fuel, initially to suck in the fuel. Then if you immediately uh, place the hose on the receiving container, so the process would continue. It will continuously flow through the hose going to the receiving container out from the old container. So that is the what is happening in the siphoning process. Okay. If the trap loses water seal, the home is open to flow of sewer gas. Okay. So, and that means trouble. Okay. So, if, for example, the water closet is not being used for a long time, little by little, the water seal will evaporate. And now, what will happen? There is no water seal. Seal meaning the bad smell and the potentially explosive gas in the inside the water closet will come out, okay, come out through that toilet bowl. Okay, will come out. So the water seal prevents that from happening, because gases cannot pass through water. Gases cannot pass through water. Okay, so the water will prevent. That's why you have to immediately pour in water to the water closet. Okay, even if you are not yet finished taking a poop, so during taking a poop, you can pour in water little by little. Okay, so that the amount of bad smelling gases will immediately decrease. Okay? A plumbing vent protects the water seal by allowing air into the DWV pipes. Okay, so because of the vent, so it protects the water seal. So without without that vent, okay, so there is always a negative pressure to siphon the water seal. So the water seal will always be broken. So we have to maintain the water seal. So if the water seal is broken, so all of the water will be flowing to the drain pipes, and thereby the noxious air and potentially explosive sewer gas would be present on the toilet and bathroom. Okay? The air provided by the vent replaces the air. So it also replaces the air, the fresh one, okay, that is drawn along with the flowing water. This replacement air reduces the suction and protects the trap. Okay? Without properly sized and installed vents, the DWV system will not function as intended. So, this process, take note, very simple one, very simple, but very detailed in this explanation, and we are now aware that it is not actually a very simple process. There are several things that are going on. There are several things that are going on that are being done by proper use of water seal. So charging, discharging, and so on. Okay. So that is the objective of having plumbing vents, is to protect the P-traps water seal. Okay. So we cannot make that insignificant, because it is very important. For example, here we have vent pipes that should extend in an upward direction from the drains. This ensures that wastewater cannot flow into the vent pipe and block it. Okay? So at the opposite end, the vent pipe should connect to an existing vent stock or stock vent. Okay, vent stock or stock vent. So when we say stock, again, that is a vertical pipe at a point at least 6 inches above the flood rim of the highest fixture draining to the system. Okay, as you can see here, we have vent pipe, okay, vent pipe, and we have drain pipe. Okay, so always we need this air. We need this air so that the noxious air would get out, the explosive gases would get out. Okay, and at the same time, we break the negative pressure that may gather, that may build up inside the pipe. Okay, so without this, negative pressure may build up. Okay, so vent, slope, and connection to pipes. This is now our main concern. So after discussing the purpose and objective of P-trap, how it is important for the vent to be there in order to trap to function properly. So how our vent connect to pipes. So plumbing vents requirement. Number 1, install an approved vent for every trap, okay, and trap fixture. This means that every plumbing fixture, such as a sink or shower, and every plumbing fixture with an integrated trap, such as the water closet, must be protected by an individual vent or approved vent system in which one vent protects multiple fixtures. So this is a code provision. Okay? So, each and every. Okay? Each and every. Number 2, terminate at least one vent outdoors. Okay? At least one vent outdoors because this is a series of connected pipes going outside, and even if only one vent is connected outdoors, so every connected pipes to that would flow. So there are very complicated connection of pipes, right? But you can design those with only one connection to outdoor. So therefore, all of the connected pipings will flow to that single outdoor connection. Connect the outdoor vent to the building drain or to a branch or extension of the building drain. The branch or extension cannot be an island fixture vent. Okay? So, any branch or extension cannot be an island fixture vent. Island meaning isolated. Okay? So, any branch cannot be isolated. So, they must be connected. Okay? How about vent pipe slope and support? So, how to expect what to expect according to the code. You have to install all vent pipes using adequate support so that the vent pipe is sloped toward the soil or waste pipe. So they are also sloping. So just like this. Just like this. It is using 45 degree slope right now. Okay? So toward the drain pipe. It is sloping toward the drain pipe. Okay? Moisture in any form should flow toward the soil or waste pipe by gravity. General codes do not specify support intervals for vent pipes. So there is no specification of how much are the spacing for different pipes, for the vent pipes in particular, how much is spacing for the vent pipe support. Okay. Supporting vent pipes at the same interval required for drain pipes is recommended but not required. Okay? So we need the support, but supporting it with some fixed spacing is not required. I think there is a maximum. Okay, for what? For safety. Okay. Support vent pipes so they slope toward drain pipes like this. As you can see, it is very clear that it is sloping down. So therefore, this is the direction of air going up. Okay? So this is because this is going down. So therefore, it is going up like that. Okay? So as you can see, one vent support, another vent support. Okay, so you can see the hook. We have the hook type hanger. Okay, there's a hook type hanger there. Okay, or connector. Okay, so vent pipe connection to horizontal drainage pipe. Okay, connect vent pipes to horizontal drainage pipes above the center line of horizontal drain pipes. Above the center line. Okay? This protects the vent pipe from filling with solid material. So above the center line. So we have to connect. For example, here again. So this is the center line. Okay? So this is the center line. So we are connecting it above here. So this is above the center line. Okay? Okay, so it is not without thinking. It is planned. It is designed to be like that. Okay? Vent connection height minimums. Okay, number 1, connect dry vent pipes to vent stock vents, and to stock type air admittance bulb so that the connection point is at least 6 inches above the flood rim. Okay, this is the second time that this provision was mentioned. Okay, 6 inches above the flood rim level of the highest fixture served by the vent. Okay, so the connection point should be at least 6 inches above the flood rim level of the highest fixture served by the vent. Okay, flood rim. What do you mean by the flood rim level? So that is the supposed to be the level of water that the highest level of water that could be collected on that particular fixture. Okay, so every fixture has its own flood rim level. Okay, for example, lavatory, there's a flood rim level. Okay, so a common violation of this provision is when is when a dry vent runs parallel to the drainage pipes under the fixture. Okay, so dry vent. So there are two types of vent. There is a dry vent and there is a wet vent. So wet vents like this must really be installed with slope because water will flow in and air will flow out. Okay, so that is for wet vents. But for dry vent, that is really a dry vent, so it is not really necessary, but we cannot control that from happening, so it is provided in the code to have the proper sloping of this pipe. So this provision helps protect the vent pipe from filling with solid material. So we do not know, for example, rats, okay, and old rats may die inside this vent. Okay, so the carcass of the rats would be a solid material that would be stuck up from that. So therefore, it would clog the pipe. Okay, so there are plenty of insects that will use or be inside this pipe, and they may die inside the pipe, and they will be the reason for this clogging. Okay. Install horizontal branch pipes at least 6 inches above the flood rim level of the highest fixture served by the vent. So we need to install horizontal branch vent pipes. Okay. So again, there is a provision 6 inches above the flood rim. Okay. So okay, if you can recall here, okay, so that, okay, the connection point when we are connecting dry vent pipes to vent stock, or dry vent pipes to vent stock, stock vents, and stock type air admittance bulb, they are vertical. Okay, so even though we are connecting dry vent pipes, okay, so they must be connected at least 6 inches above the flood rim level of the highest fixture. Okay, here we must install horizontal branch. Okay, branch meaning horizontal. Okay, vent pipes at least 6 inches above the flood rim level. So the third time that this provision is mentioned, 6 inches above the flood rim level of the highest fixture. Okay, Okay. So vent wrap in for future fixture. For wrapping in. Okay. So vent wrap in for future fixture. Install a vent for wrap in. Okay. Fixture that is at least 1/2 the diameter of the drain pipe wrap in. So another provision for the future. Okay. At least 1/2 the diameter of the drain pipe. Okay, so we have a drain pipe and at least 1/2 of that size, we have to install a vent for wrap in. Okay. Then connect the wrap in vent to the vent system or provide another approved means to terminate the wrap in vent. Okay. So we need to connect that wrap in vent to the system. Okay, or we can have this separate termination. Okay, then label the wrap in vent pipe to indicate that it is a vent. So, or sometimes we can do the color coding of pipe so that we know what is vent, we know what is drain, we know what is waste. Okay, so DWV, drain, waste, vent. So what about crown venting? Connect the vent fitting at least 2 pipes diameter from the trap weir. Okay, trap weir at least 2 pipe diameters. Okay, that is crown venting. Okay, violation. As you can see on the right side of your screen, do not connect the vent pipe within 2 pipe diameters. Okay, so this trap weir. So civil engineering, you must know what do we mean by weir. Okay, so you have the hydraulic subject, you have hydrology subject, you have the water mechanics, fluid mechanics. Okay, so weir, trap weir, so meaning storage of water. So water would be stored here, okay, in this P trap. Okay, so in this trap, do not connect the vent pipe within. Okay, so within this one, the distance of this to this. So this is the vent. This is a wet vent. So this is a wet vent because water, this is a drain DWB system. So water will go down here, but the vent is going up there. Okay, this is a vent. So this is a wet vent. Okay, do not connect this vent pipe. So we are talking about this. This is the vent pipe. So this is the vent pipe. Wet vent because it also served for water or waste drain. Okay, within meaning less than 2 pipe diameters. So this is the diameter pipe. So the distance from this point to this point must be more than 2 diameters of that pipe. Okay, so that's why it is a violation. Okay, so it needs to be a little bit farther, not closer than this. Okay, so connect vent pipes on the left side of your screen. Connect vent pipes to other vents at least 6 inches above the highest fixture, so that the vent pipe will not become clogged with solid. Okay, so 6 inches vent pipes to other vents. So this is for vent, this is the vent, this is the branch vent. Okay, So connect it at least 6 inches. So this is supposed to be connected to the lavatory. Okay? This is supposed to be connected to the lavatory. So what we mean is here, flood rim level of the highest fixture. Okay? So a fixture will be connected here. What kind of fixture will be connected here? For example, sink, kitchen sink will be connected here, or lavatory will be connected here in this position. Okay, connected here. And then, for example, a kitchen sink like this, there is a flood rim level up to this point of the kitchen sink, and then this flood rim level up to this must be more or equal to 6 inches. Okay, this is the vent. So do not connect this vent here in this location, so it must be up there, being 6. So here, as you can see, this is about 1 foot or more than 1 foot, the distance from this point to this point, because you will still put in the fixture. The fixture will be placed right here like this, okay? And the maximum level would be about here. So this maximum level, flood rim level, up to that again is supposed to be 6 inches and more. Okay. So any question? Any question? So now I would like to take a look on vent termination. So vent height above roof. So extend vent pipes above the roof at least 6 inches or the number of inches required by the local snow accumulation. So we do not need this because now it is for United States because of snow. Okay, in our country only rain and typhoon. So what we are trying to do is on your right side of the screen, you have the picture of vent above the roof, and that is supposed to be 6 inches above the roof, as you can see there. Okay, that is more than 6 inches. Okay, as you can see on that picture. Okay, as you can see in the picture just below me. Okay, so here, right, just below me, so you can see this roof placement of the vent pipe is more than 6 inches. So this is good. Okay. Measure the vent height from the high side where the vent exceeds the roof. Obtain the snow accumulation height from the low. So how to measure this? So here, measure from the high side. This part is the high side. This part is the low side. Do not measure from this side. From this side going there. From this side going there. So measure from the high side. This is from the low side. Okay. So we need to measure it from the high side. From this point going up there. That is still more than 6 inches. That's why this installation is okay. Let's go back. Extend the vent pipes at least 7 feet above any roof. Okay. So we need to extend vent pipes at least 7 feet above any roof used as balcony. So this roof is not balcony. So this is not used for balcony. So 6 inches protrusion is okay. So it is protruding about or more than 6 inches. Okay. But if this roof is being used as occupancy, for example, balcony, for balcony use, therefore there are people that may be staying there okay, for some longer period of time, okay, hours and hours of stay there of occupants. So we need this pipe to be as high as 7, okay, 7 feet, 7 feet. So the average human being is 5.5 to 6. So that's why it is 7. Okay. So therefore, any occupant may not be able to smell, okay, the noxious gases, okay, because of this. Do we follow? Do we follow? Vent freezing and frost closure protection. So we do not need to tackle this because this is for countries with winter. So let's jump to the next. Vent flushing. Use approved flushing to make vent pipes extending through a roof watertight. So what do we mean by flushing? So this is what we mean by flushing. This plate right here is what we call flushing, right? This plate, flushing. The purpose of this is to prevent rainwater from coming inside the building through this pipe. So because of this, so this is flushing because of this flushing. And as you can see, there are black sealing components. Okay, so the flushing is sealed up with sealant. Okay, so there are sealant underneath this flushing plate. Okay, okay, and use cork to make vent pipes extending through a wall watertight. So cork. So that is the sealant, what we call cork. That is the sealant. And for vent exterior termination location, locate plumbing vent termination at least 4 feet below, at least 3 feet above, or at least 10 feet horizontally from any. Take note, 4 feet below, 3 feet above, 10 feet horizontal from any door or operable window. Okay. Other air intake opening of the building and air intake opening of any adjacent building. Okay. Up to the adjacent building. So, for example, you have a door, okay, and then you will install the vent. So we need horizontal the distance from the door of about 10 feet. Okay, 10 feet horizontal distance. When the vent is crossing the door above the door, so that is 3 feet. Okay, 3 feet. And when it is crossing below the door, that is 4 feet. Okay. So those are the requirement. Below 4 feet, above 3 feet, and horizontally 10 feet. Okay. Next is to locate plumbing vent termination running through a side wall at least 10 feet from the lot line and at least 10 feet above the highest grade. So, vent termination. Okay. If the vent termination is passing through, okay, side wall, at least 10 feet from the lot line, okay, at least 10 feet above the highest grade. Okay, so 10 by 10, no? Within 10 feet horizontally from the vent termination. Okay, so So 10, 10, and 10. So 10 from the lot line, 10 above the highest grade. Okay. So 10 horizontally from bend termination. So that is for the location of termination running through a sidewall. Okay. And protect sidewall vent termination from entry by birds or rodents. Okay. Usually, birds and rodents may die inside this vent. Okay. Do not locate vent termination directly under buildings overhang. Avoid the termination in the overhang if the overhang contains soffit vents. Okay. So avoid, okay, using the overhang for our location of termination. Okay. So as you can see here, using the approved vent flashing boots to seal around the vent projection in a roof. Make sure boot angle is compatible with your roof slope. So this is what we call boots. Okay. So this flashing is provided with boots. Okay, it's a boot part. Okay. So flashing boots so that it is sealed off properly. So in our country, I don't think we have this type of component in the hardware available. So you have to order it from outside the country, or if the project is so big, you can order it from other country. Okay? Because you can look at any local hardware and you cannot find. So our plumber do these things with so much creativity. Okay, so doing flashing, and that's why sometimes their creativity fail them sometimes. And what happened? Within 1 week, within 1 month, water will coming inside the house. Okay? Vent connection distance from trap. Okay? We have a table for distances to determine the maximum length of a fixture drain between a trap weir and a vent fitting. A vent fitting may be at a vent pipe such as the individual vent, or a vented pipe such as a wet vent. That is what we call the wet vent, vented pipe. Okay? Uniform Plumbing Code, okay? UPC. Uniform Plumbing Code is an international code that also specifies standard distances, okay, for length of a fixture drain between trap weir and vent fitting. Okay, so we have a picture. We have a picture here. Okay, so this is vent fitting. This is a vent fitting. So this is what we mean by vent fitting. And then the trap weir. This is the weir. Okay? Trap weir, so there is a maximum vent distance. Okay? So that is what we mean by vent fitting. This is the vent, and this is the vent fitting. Okay, so this vent fitting is what? This uses sanitary fitting. Okay? So we already learned this type of fittings last meeting. There are several types of fitting. We learned almost the common, almost the basic and common fittings we already learned last meeting. So the table does not apply to self-siphoning fixtures such as toilet. No fixture drain length limitation apply to this type of fixture. So for a self-siphoning fixture, there is no provision for maximum length of fixture drain between trap weir and vent fitting. Okay. Fixture drain slope. Connect the fixture drain pipe with not more than 1 pipe diameter of pole between the bottom of the trap outlet and the bottom of the vent fitting inlet. Okay. So for fixture drain slope. Okay. This parallels the distance requirements in table 37 and reduces the chance that the trap will drain because the fitting is below the trap. Okay. Example, 5 feet by 1/4 inch per foot equals, okay, so that is the slope, no? 5 feet by 1/4 inch foot equals 1 and 1/4 inches, okay? So that is the example computation, okay? So if you multiply 5 by 1/4, so that is 1 and 1/4 inches. Then connect the top of the fixture drain pipe to the vent fitting above the trap weir. This provision does not apply to toilet fixture again because it has its own P-trap. So for those fixture with its own P-trap, this table 37 will not apply. Okay, again, connect the fixture drain pipe with not more than 1 pipe diameter of pole. Pole meaning sloping down. That is what we mean by pole. So 1 diameter of slope between the bottom of the trap outlet and the bottom of the vent. Okay, the bottom of the trap outlet, so the bottom here, and the bottom of the vent. So this is the bottom of the vent, the bottom of the trap outlet. So the slope is 1 diameter. Okay, so as you can see here, so do not do it more than 1 pipe diameter. So okay, so do not do it more than 1 pipe. So as an example, we have here what? Again, if the distance is 5 feet, so 1/4, so therefore 1 and 1/4 inches. Okay, let's look at the table 37. Vent distance from trap. Okay, so we have trap size 1 and 1/4. Slope is of course 1/4, okay, per foot. Okay. Distance from trap to vent fitting 5 foot. Okay, so therefore you just have what? Multiplied 5 times 1/4, so 1 and 1/4. Okay. Another trap size 1 and 1/2. Slope 1/4 for 6 feet. Okay, if you multiply 6 feet 1/4, the answer is 1 and 1/2. Okay, so another trap size, so different trap sizes. Okay, meaning this is a diameter of the trap. Okay, diameter of the trap. Okay, so diameter of the trap. If the trap diameter is 2, so the trap diameter must be the same as the diameter of the pipe. Okay, so that is the meaning of this. Okay, so if you have trap size 2, So the distance from trap to venting, again, this distance, this to this, that is the vent distance, 8 feet if you have a trap size of 2. If you have a trap size of 3, the distance is 12 feet. It depends upon the size of this trap. What is the size of this? So that is the distance of this. Okay, so just multiply. Okay. Okay, so if the trap size is given, then you have to divide. 2 divided by 1/4, that is 8. Okay, but if you have the distance, you need to multiply in order to find the trap size. Okay, okay, for example, you are given a trap size of 4. The trap size of this pipe is 4 inches. Okay, meaning the diameter of this pipe, 4 inches. What must be the maximum distance? So divide. So 4 divided by 1/8. So that is 16 feet. Okay, so take note. 3 and bigger. So for pipe size of 3 and bigger, the slope is 1/8. For smaller pipe sizes, the slope is 1/4. Okay? So the pipe, as the pipe becomes bigger, the slope will become smaller. Okay? Do you follow? Okay. Pipe size 3 and 4, slope 1/8. So therefore, ay. Take note. However, don't be confused. There are always confusion going on here because some of the plumbers actually miscalculate the maximum distance. Okay, so this is, for example, 4 inches diameter. So this maximum distance is only 16 feet. Okay, 16 feet from where to vent pipe, 16 feet. So you need to divide 4 divided by the actually you divide by 1/4, not 1/8. So 4 divided by 1/4. So always divide by 1/4, not 1/8. Although the slope is 1/8, but you have to divide by 1/4. For example, 16 times 1/4, the answer is 4. 16 times 1/4 is 4. So the multiplier is always 1/4. The multiplier is always 1/4. But the slope is not, you will not do it with the slope of 1/4. You have to do it with the slope of only 1/8. Okay, so there must not be a confusion there. Okay. Next, improper vent connection pictures. So we have this. No? So we also have a picture, for example, of correct individual vent configuration. Okay, let's take a look on this left side picture on your screen. When a vent is connected to a vent stop, the connection should be at least 6 inches above the fixture flood rim level. So I already explained this. Okay, this helps avoid improper waste flow through the trap. Okay, so that is the purpose. Now, This is what we mean by flood rim level of the fixture. So not the pipe. The pipe is only up to this point. Okay? Take a look. But the flood rim level of the fixture is there. For example, this is a kitchen sink. So the kitchen sink flood rim level, okay, this is the rim of the kitchen sink. So that must be the flood rim level because this is the rim. Okay? So this branch bend, this bend must be placed above this flood rim level, above 6 inches above. So this is wrong. This is a wrong connection. Okay, this is a wrong connection. So bend connected below flood rim waist through horizontal bend. Okay, so this is wrong. Okay, this is a wrong connection. This horizontal bend pipe must be placed somewhere here. Okay, above this flood rim level. Okay, so bend stock. This is the bend stock. So this is the drain. This is the drain, and this is the wet bed. Okay, so this is the dry bed. This is the wet bed. Okay, so in this one, that's why it is an example of improper bend connection. Example of proper bend connection is good because this is the flood rim level and this is connected more than or equal to 6 inches above. Okay? Okay? So there are two kitchen sink, lavatory and kitchen sink. And the branch bend is connected 6 inches above the highest flood rim level. So this is the highest flood rim level. This is not the highest flood rim level. This one is. Okay? So this is the correct or proper bend connection. Okay? Okay, sorry about that. On your right side figure diagram, you have the example of correct individual bed configuration. Okay, the gray portion is our bed. So the gray portion is the bed here. Is the gray portion. Gray portion. So fall of drain less than 1 pipe diameter. So the fall of this. Okay, meaning the slope of this. Okay, so 1 pipe diameter. So the diameter is 1 inches. So 1 inch diameter. So the slope must be 1 inch. Okay. So here, okay, the distance from this point to this point must be 2 times diameter. The distance, okay, from this point to this point, 2 times the diameter. Okay. So this is what? Here. This is maximum bend distance from the weir to this. Okay. Okay, so 2 times the diameter of pipe, the distance from this point to this point. But the maximum is times 4. The maximum is times 4. The minimum is times 2. Okay, this is the minimum. Okay, minimum times 2, maximum times 4. Okay. Vent pipe at least 2 times pipe, so at least 2 times the pipe diameter. Okay, So vent pipe size. Use at least 1 1/4 inch diameter. So this is the smallest vent pipe size, 1 1/4. Okay. Or a vent pipe at least 1/2 the diameter of drain pipe being vented. So whichever is larger. So meaning to say this is the smallest vent diameter because the condition whichever is larger as the dry vent. Okay. So for example, what is the diameter of this? What's the diameter of this? For example, this is 1 inch diameter, so this could be 1/2 because it could be what? At least 1/2. At least 1/2 of this. But cannot be because it is 1 1/4. So 1/2 compared to 1 1/4. So 1 1/4 must be the size, okay, of this vent. Okay. And then increase the vent pipe diameter by at least 1 pipe size over the entire length of the vent pipe when the vent's development length is greater than 40 feet. Okay. So if the development length 40 feet, okay, so increase the vent pipe diameter by the next higher size. Okay. For example, you are already using 3 inches diameter pipe, and the length of the pipe would be more than 40 feet. So use 4 inches rather than 3 inches. Okay, because the next diameter is 4. Okay. Vent pipe development length. So development length. Measure the developed length of individual branch and circuit vents. So we have to measure it, beginning where the vent connects to the drainage system. Okay. So this is the starting point. How to measure the development length of the vent pipe. Start from the drainage system and ending where the vent connects to the vent stock. Okay, so vent stock vent or air admittance bulb, or the vent's termination point outside the building. So that's how we measure the development length. So individual vents. Fixture type. Use an individual vent to protect any fixture. Okay. So if you are using individual vents for each fixture, you are using individual vents for each fixture. Use individual vents to protect any fixture. Okay. Number of fixture. Use an individual vent to protect only one fixture. Okay. One fixture, one vent. Fixture location. Use an individual vent to protect one fixture located anywhere in the structure. Okay. And then individual vent connection location. So these are all for the individual vent. This condition, this provision is only for individual vent. Okay. Individual vent. Connect the individual vent on the fixture drain of the fixture being vented, or at the fixture drain connection to the drainage system. Okay. And number 5, fixture drain length to vent connection. Use table 37 to determine the maximum distance. Right. So maximum distance is pipe diameter times 4. Okay. Between the fixture trap weir and individual vent fitting. And number 6, individual vent pipe size. Use at least 1 1/4. Okay, so at least, so meaning it is the minimum. Or a pipe at least 1/2 the size of the drainage pipe being vented, whichever is larger. Okay. So this could be an example of vent support. This is a vent support. It is a strap type of support. Okay. So this is our vent fitting. So vent fitting, which is sanitary thing. Okay. Individual vents are the easiest to install. They protect one fixture because of that. Okay. Then common vents. So it is not individual vent, but common vents, meaning there are several fixtures using this vent. Fixture type. Use common vent to protect any two fixture. You may common vent different types of fixtures such as a sink and a shower, or a shower and a toilet. Number two, number fixture. Use a common vent to protect only two fixtures. Okay, only two fixtures for common vent. Number three, fixture location. Use a common vent only for fixture located on the same floor. You may connect the fixture drains at different vertical levels if the fixtures are on the same floor level. You can connect fixture drains at different vertical levels. They have different levels, but they are on the same floor. Okay? You cannot do it connecting the vent with the common vent from one floor to another. Okay. Number four, common vent connection location. You may connect the common vent where the fixture drains intersect. Okay. You may connect the common vent downstream from where the fixture drain intersect only when the fixture drains connect to the branch drain pipe at the same horizontal level. Fixture drain length to vent connection. Use table 37 to determine the maximum distance between each fixture trap weir and the common vent fitting. So table 37 is both used for individual and common vents. Number 6, common vent pipe size. The same, 1 1/4 or 1/2 of the drain pipe vent, whichever is larger. Okay. So common vent here. So vent support strap. Okay. Support strap with double sanitary. Double sanitary. One here, another here. So common. Only two is possible. Only two fixture. So one fixture here, another on the other side. Okay. And then bend upward. Okay. Wet vents. Okay. How about using wet vents? Use a wet vent to protect any combination of fixtures from not more than two bathroom groups. Okay. Not more than two bathroom groups. Okay. Any combination of fixtures. Okay. So you can use wet vents. Okay. So this is for wet vents. Use wet vents to protect more than two outlets, two bathtubs or showers, two laboratory sinks, and two bidets. Not more than, okay? So use wet vents to protect not more than, okay? So two, okay? Two bidet, two laboratory, two showers, two bathtubs, so on, okay? Number 3, use a wet vent only for approved bathroom fixture located on the same floor level. Wet vent connection location. Begin with a wet vent with an individual or common vent for laboratory, bidet, shower, or bathtub. This vent does not need to be at the first wet vent fixture in a horizontal wet vent. This vent must be at the first wet vent fixture in the vertical wet vent. And the wet vent, the last wet vent fixture connection to the wet vented pipe. Do not connect more than one fixture upstream from the beginning, individual or common vent in the horizontal wet vent. Do not connect more than, okay? More than one. So there is the first fixture, then another one along the line, and not more than one. So one and one. So there are only two, okay? Not more than two. Okay? Connect is picture individually to the vent pipe. Do not connect two or more fixture together. And connect that branch drain to the wet vented pipe. So horizontal wet vent fixture drain, connect its individual fixture drain horizontally to horizontal wet vented pipe. Example, you may not install a Y fitting vertically and connect the fixture drain to the vertical opening of the Y in a horizontal wet vent. You may install the Y horizontally and connect the horizontal fixture drain to the horizontal opening of the Y. Okay? So, if you are using the Y fitting, okay? Okay? And vertical wet vent fixture drain connection location. Connect all toilet fixture drains at the same vertical level for our location. Connect fixture drain from bathtub, shower, laboratory sinks, and bidets at or above where the toilet fixture drains connect. At or above. Okay? For toilet or water closet, the same level. Okay? But for the others, like bathtub, shower, laboratory sink, and bidet, above where the can be at the same level or above, where they cannot be below. Okay? Where the toilet fixture drains connect to the vertical vent. Again, we can use table 37. Okay? To determine the maximum distance between each fixture. So then wet vent pipe size 1 in 1/4 again, and 1/2 of the size of the vented pipe, whichever is larger. Again, use table 38. So now we have the next table 38. Okay, so we can take a look at it. For horizontal, you may not connect a toilet to a drainage pipe smaller than 3 inches regardless of what is allowed in the table. Whatever the table suggested, you have to use water closet drain pipe. Okay? At least 3 inches. Okay? So the plans of the water closet is 4 inches, but the minimum you can use is 3 inches. So therefore, do not follow the table if the table indicated smaller than 3 inches. That is what we mean by this. Okay? So in the picture, using a wet vent eliminates the need for individual vent for each fixture. So that's why it's very convenient to implement wet vent. So to minimize the number of pipings. Okay? So we have wet vent here. Wet vent ends at the last wet vented bathroom roof fixture. So this is the end point. So this is the vertical separate vent. Okay, so this is P-trap. So P-trap, all wet vent fixture connect horizontally to wet vented pipe. So this is wet vent. Fitting installed horizontally if you are going to connect this to vent like this. Okay. Why? This is the why. This is the explanation for the why that we already discussed. Okay. This is how the why fitting is supposed to be connected. Okay. So for what double solidarity, right? So this is common. This is what we call common vent. So one here and one for the other. Okay. Okay. Island fixture vent. So there are an island. Okay. So fixture type. So use an island fixture vent to protect only sinks such as those in kitchen and bathroom. So you may connect a dishwasher and disposal to a kitchen sink. Okay. Dishwasher can be uh, connected disposal to a kitchen sink. Okay. Use an island fixture vent to protect any number of approved fixture type. Any number for an island fixture vent. Okay. There are no other solution because it is an island vent. So you have to connect everything to that. Okay. Use an island fixture vent only for fixtures located on the same island, the same floor level. Only on the same island. If there are so many fixtures on that island, you have to connect them all without regard to the number of fixture. But don't connect it to the other island. Okay? On the same island alone. Okay? Pipe configuration. Okay, extend the loop portion of the island fixture vent vertically to above the drain outlet. Okay. Use drainage fittings and pipe slots for any portion of the vent below. Okay, and connect the downward portion of the vent loop downstream from where the fixture drain connects with the horizontal drainage pipe. Okay, and provide clean outs at the downward portion of the loop vent and in the vertical portion of the island. It uses looping of the pipe vent. So there is a loop. Okay. So dry vent connection location. So connect dry vent to the drainage system using pole size fitting. Connect the dry vent to a vertical drain pipe. Extend any dry vent at least 6 inches above the floor rim. Again, we already discussed those. Fixture drain length to vent connection. Again, use table 37. And size of pipe is again 1/4 or the 1/2 of the size of drain pipe size. Okay, whichever is larger. Okay. So, table 38, horizontal and vertical wet vented drainage pipe size. Okay, wet vented pipe size 1 1/2. So we can use 1 1/4, but for wet vented 1 1/2, 2 inches. Here 2 1/2, 3 and 4. Okay. Maximum drain fixture load 1, 4, 6, 12, 32. These are the fixture load. Okay. So that is for table 38. This is for table 38 here. Okay. Table 38. So that is using the table 38. That is for what? For wet vents. So for wet vents, we can use table 38. Here. Air admittance bulbs. Okay, what about it? So bulbs is the component that can open and close or control the flow of fluid, meaning either gas or liquid. Okay. Install air admittance bulbs according to manufacturer's installation instruction, general code provision. You may use bulbs to vent individual vents. Okay. Branch vents, circuit vents, stack vents. Use individual and branch type air admittance bulbs to vent fixtures that are on the same floor. Okay. Do not connect admittance bulb from different floors level. Okay. Use admittance bulbs that are rated for the vent size to which the bulb is connected. So the bulbs must be rated for the vent size. Okay. And Locate individual and branch type and bulbs at least 4 inches above the horizontal branch stream or fixture being vented. The location must be at least 4 inches, okay, above the horizontal branch. Okay. So usually we attach the branch vent 6 inches above the flood rim level. Okay. But here we are attaching the air admittance bulb at least 4 inches above the horizontal branch stream. Then location of the bulb is at least 6 inches above the flood rim level. Okay, so locate the bulb within the vent's development limits. So development length. Okay, within. So if it is less than 40 feet length, so it is the same as the pipe requirement. But if it's more than one pipe size increase, we have to increase the size of the bulb also. Okay, locate the air admittance bulbs in attics at least 6 inches above insulation. So there are insulation for this ceiling and roofing, so at least 6 inches above. Provide air admittance bulbs with access and adequate ventilation. So air admittance bulb, it admits air. It is its purpose is to to regulate the flow of air going inside the system or going outside the system. But as you can notice, there are wet vents. Okay, so it may also control the flow of fluid, including the liquid portion. Okay. Provide air admittance valve with access and adequate ventilation. Install these valves within 15 degrees of vertical and do not install air admittance valves outdoors. Okay, not necessary for outdoors. 15 degrees of vertical. Okay. Do not choose an air admittance valve as the vent for sewage ejector tank. Okay, sewage ejector tank, unless the vent system for the tank is designed by an engineer. So for venting a sewage ejector tank, do not choose admittance valve unless it is designed by an engineer. Then look for the UPC. This is the code. So Uniform Plumbing Code symbol for the admittance bulb. Okay, so that is the for the plumbing plan drawing. Okay, the symbol. So IRC is the International Residential Code. Okay, which have the different design parameters for Uniform Plumbing Code. Okay, so like this, island fixture vent is a fairly complicated venting configuration used to vent fixture installed in a kitchen island. To further complicate matters, many codes now require that the vent pipe from the fixture connect to the vent stack at least 6 inches above the fixture flood rim. Okay? So, island vent, fixture flood rim. So, this is a what? Violation because this is the fixture flood rim. So, this island vent must be 6 inches above. Okay? So, it is now complicated because this is an island. This is an island. This is the kitchen island. This is the kitchen island. So, the island vent will protrude over this. So it is visually what? Bad. Okay? How can you put in additional what? You have to put in additional part like this in order for this island bed to be covered. No? Because it must be covered when you are in the kitchen. You are always visually looking directly at the island bed. And you know the island bed contains foul-smelling noxious gases. So in the kitchen, so it is very what you can imagine so many things with that in the kitchen. So you must cover it. So like this, there must be a covering. So this is an island. So the covering would become more complicated because of this requirement. It must protrude 6 inches above the maximum flood rim. Okay, so this is the vent stack, vent pipe. So vent stack, vent pipe, and then drain pipe. Okay, so this is the drain pipe. So drain pipe. So this is also what? This is 4 inches. 4 inches. This must be 6 inches above. So those are the requirements. Air admittance bulb. No. This is if you connect air admittance bulb here. So this must be 4 inches. But if this is only pipe, this must be 6 inches. 6 inches. We can go back to the table. Horizontal and vertical wet vent drainage pipe sizes. Okay? So their load. Okay. So if this is 2 inches, so the load is 4. Okay? So air admittance valve can be installed in an island cabinet. So you need to cover those things by a cabinet. To vent a sink drain line, greatly simplifying venting process. So this is an additional cabinet just to cover those pipings, so vent pipes. Okay, and any question? Any question up to this point? Before we go to the next. Next topic is plumbing traps. So which is related? This is a related topic to plumbing vents. So plumbing traps, plumbing vent. Okay. So before that, we will stop it right here. What we'll do is to stop our discussion right here and then restart another live stream lecture session for the next topic. Okay? So again, this is your professor, Dr. AP, preaching